What? Yeah, now it's working. Hi everybody. Now we're going to have a highly specialized talk about some crazy Linux specifics by Mr. Patterson. Please give him a warm welcome. Thank you.
Good afternoon, and thank you very much for attending this presentation on computer forensics and crypto key recovery from Linux memory dumps. I know that this is a highly specialized talk, and I have a lot of small printed details. So if you want to move up closer, if you can't see anything, please do that. My name is Torbjörn Pettersson, and I work as a computer security consultant for a Swedish firm called Nexus Security, and I do some computer forensic work as well as part of my job at Nexus. And it is in this line of work that I've been introduced to computer forensics and crypto key recovery. In the last few years, since the US government decided to change their policy on cryptographic export, there's been a boom, or it starts to flourish, a lot of different cryptographic solutions for especially Linux and other platforms as well. And this has provided us with new tools and new ventures for disk encryption and file encryption that simply wasn't possible before as easily to what we perhaps could call the consumer. The ease and popularity of these tools has provided, or rather given, forensic examiners a formidable challenge, as people who actually have legit paranoia, we could say like hackers, pirates, dissidents, and other people have started using these type of tools en masse. In this presentation, I will try to go into details on how to attack these systems and how to recover the cryptographic keys used when encrypting disk storage and when encrypting loopback files. I'm not the only one who has been doing research in this area. A guy named Maurits Burdach has actually written a really good document and research how to recover other types of information or forensically interesting information from memory dumps. And a guy at IBM named Wietse Venema has also done a lot of research on the Windows platform on how to recover not only cryptographic keys and encrypted files, but also other forensically interesting information such as process list, running programs, open network connections, and such. So there's a number of different disk encryption options for Linux. I've been looking at CryptoLoop and dmcrypt, but there's also TrueCrypt, an open source multi-platform encryption solution. We have LoopIS, that is a kind of a relative to CryptoLoop, and I also believe BestCrypt is what is it called? A commercial version as well. All of these solutions have one thing in common. They have to store the encryption key in memory out of necessity, otherwise it won't be possible to use. There are, of course, hardware implementations as well, but all of these software implementations share this common weakness that in order to be able to do the encryption or run the encryption algorithm, it has to have the key available in memory out of necessity. When disk encryption is done right, it's virtually impossible to break. And as with any type of security solution, it's never stronger than its weakest link. And I will try to show you how to attack one of those weak links that is in common in CryptoLoop and dmcrypt, namely the fact that it has to store the encryption key in memory. So, of course, one of the prerequisites for doing this is that we have a copy of the memory. And at the end of this presentation, I will go into details on how to actually acquire one of those memory dumps. But I will start out with going into details on how to extract cryptographic keys out of an existing memory dump. So how you actually got hold of this memory dump isn't so much interesting for what we're trying to do, but it comes into play when you're actually trying to perform this attack on someone. So we start out by assuming that you have a memory dump. So the crypto loop. I remember using the crypto loop or something similar to it back in the 2.0 Linux kernel 2.0 series. It was available as patches, and I've been doing some Googling on it, and I haven't really been able to find any information who actually wrote that. But I believe that it is somehow related to the version we have today. Since the 2.2 series, it's been available as patches for the 2.2 and 2.4 and, well, probably 2.6 series as well. What happened was that the US government actually released the embargo on encryption technologies, and what happened then was that we saw the introduction of the crypto API into the Linux kernel for the 2.5 series and 2.6 series, and once that was introduced, the cryptographic layer could be used by CryptoLoop as well, and CryptoLoop has been marked as deprecated in the 2.6 series, and for a number of different reasons it's been replaced by dmcrypt that we will look into later. For a number of different reasons, the patches from kernel I wasn't really as good as people wanted them to be. So for this reason it spawned different versions, for instance the loop.is. The author of loop.is has a lot of things to say about the security in CryptoLoop, and I believe he's right in many cases, but I won't go into details on the different shortcomings of CryptoLoop. But CryptoLoop is basically a layer that you can put between an existing file or an existing device, and Linux has the feature of loopback mounting different medias and pretending that it is a device. For instance, you can mount an ISO image, you can mount a specific file as if it would be a file system. And these patches, or as it now is in the stock kernel, provides you with a cryptographic layer in between your actual file and the file system. So everything that goes into that file system will be encrypted. And as I said earlier, it's now included in the stock Linux kernel and available to anyone, as is dmcrypt. And of course this gives everybody who runs Linux the opportunity to use these kind of solutions. I myself use Mac OS X, and it has a very similar solution to the loop crypto. And as I said, it's been deprecated, but anybody who actually used it before is probably going to use it for a long time as well. So when you set up a crypto loop, you have to do keying, and it's done using the IOCTL function call, and there are two different programs that can do this for you by default. That is mount and LO setup. They are part of the util Linux package, and when this whole thing started out with the 2.2 series kernel from and the patches from kerneli.org, the patches for util Linux wasn't approved by the author of util Linux, and therefore for some reason a number of people actually wrote their own patches, and there's a flourish of different versions of util Linux patches out there that for a number of different reasons are incompatible with each other. The version that is distributed today, and I assume that the author finally accepted the patches, is not very good. So it has a number of shortcomings, and for these reasons several different Linux distributions have their own patched version of util Linux and the LO setup and mount utility that actually interprets what you're trying to do differently. So for instance, Debian hashes the password into key before it uses it at the key, while the stock util Linux doesn't. So if you're using Debian, for instance, and then switch to another distribution, you might not be able to access your crypto loop. From the kernel perspective, there's no difference between the encrypto, the keys being inputted, but since the key is inputted in different ways, using different version of LO setup or mount, the result might not be what you've actually expected. Also, I will go into this later, but there's actually a few bugs in Util Linux that causes it to behave differently even if you have the same version. So it might be worth noting that this is not a very good solution. But on the other hand, when we started out with this, it was the only solution available to us. So I know that there are a lot of people who use Cryptoloop. And actually, dmcrypt is partially compatible with Cryptoloop as well and has the same shortcomings for the same reasons. So what you have to remember is that it uses the IOCTL, and you have two different options, mount or allo setup, that you can use to input your key. So I know that this is really, really tiny for those those of you back there, but I'm going to try to explain anyway. Cryptoloop is a very, very simple solution. So when you input your key and you set up your Cryptoloop or your loopback device,